We will continue with electricity. Today we are going to study an important aspect of this lesser electricity. Okay, that is we are going to study. Last class we studied about the Ohm's law. Okay, now we are going to study about the resistivity. Okay, resistivity is a very important aspect of electricity. Okay, which is very useful. Okay, now even day-to-day life. Okay, so let's see about it. Okay, that is here what you have to understand, that is that is we studied that when the current is passing through a conductor, now the flow of that current can be opposed, that we studied. Okay, that is what we called the resistance. Okay, that is this resistance of the conductor depends on some factors. Okay, that means the resistance of the conductor, that is whether the conductor having high resistance or low resistance. What is high resistance means? Okay, if the conductor opposes the flow of current, okay, then it is having the high resistance. If the conductor does not oppose, okay, then we will say that it is having the low resistance. Now, with some factors, this resistance of the conductor depends on some factor. So, in this portion, we are going to see which factors actually, okay, depends on this, okay, resistance. That is, resistance depends on which factors. First is on its length. Okay, here the length of the resistance. Length of the resistance means, okay, it is if the length is increased, okay, the resistance also will increase. Getting? Okay, take very care. Okay, if the length is increased, okay, the resistance also will increase. If the length is decreased, resistance also will decrease. Now you know that, okay, such a case we will say that it is directly proportional to. Okay, that is resistance is, okay, directly proportional to the what is length of the conductor, L we can say. Understand? Okay, why so? Because if the length of the conductor is increased, resistance also will increase. Okay, if the length is decreased, resistance will decrease. So it is called the directly proportional to. So the resistance is directly proportional to the length of the conductor. And the other is the area of cross section. Now, area of cross section means, you know that a wire which is normally cylindrical in shape and it will have some radius. Correct? It is like this. Okay, it is have some radius here. So this area of this circle, we can say it is a circular. Okay, whatever the area of this circle here, okay, this is the area of the cross section. Understand? Now this we will represent this area of this circle, that is of this part, it is represented as A. Okay, now here the resistance is inversely proportional to the area of the cross section. Understand? Okay, now what is mean by inversely proportional to? It means, okay, if the area is increased, that is we are using a thick wire. It is like this. Now, if the area of cross section here increased, so obvious, okay, what will be decreased? Now here the resistance will be decreased. That is, if the area cross section is increased, the resistance will be decreased. Understand? Now we are using a very small wire. Okay. Now if the area of cross section is decreased, the area of cross section is decreased, resistance will increase. Understand? So it is inversely proportional to what? It is inversely proportional to area of cross section. Okay, that is what here mentioned. Okay, if the area of cross section. Understand? So the resistance, some two factors you understand. That is, one factor is length. If the length is increased, resistance will increase. Okay, if the length is decreased, the resistance will decrease. Next is the area of cross section. If the area of cross section is increased, okay, the resistance will decrease. Okay, if the area of cross section is decreased, okay, the resistance is increased. So here, what actually it means? Inversely proportional. So resistance is directly proportional to length and okay, inversely proportional to the area of cross section. And the other one factor is that is the nature of its material. Okay, now nature of its material means okay, it is made with which material? That is, if it is made with aluminum, if it is made with copper, if it is made with silver, so it is all having this material factor is also there. That is for particular, for we know that for the copper, okay, for copper it will be less, resistance will be less. For aluminum it will be also less, but a little more than that of the copper. It is for silver it is more. Okay, now while telling about like that, if it is we are using some alloy, okay, it will be again it will increase. Okay, so that the material, so resistance is also depends on the material which it is made. Okay, now here actually we will come to this nature of the material afterwards. Now first we will connect these two aspects we studied. Now when we combine these two, that is resistance is directly proportional to L and resistance is inversely proportional to area of cross section, it will come like this. Okay, resistance is directly proportional to L upon A. Understand? Okay, so now you know that if it is proportionality sign, the last class also we studied that there exists a constant. So by removing this proportionality, we can put a constant there. So we are removing that proportionality and we are writing this as R is equal to rho. It is how it is writing. It is like this here, right? Okay, like this here, right? Rho. Okay, it is of rho. Okay, into. Okay, what is rho here? Now the proportionality sign is removed, so rho is came. Rho into L upon A. Understand? It is a rho into L upon A. Okay, now here what is rho? Rho is a constant. So for a particular material, it will be a constant. That is what actually the nature of the material decision. Okay, it is this rho is the constant of proportionality and is called the resistivity. But it is resistivity. So we can say that the resistance is depends on the resistivity also. So three factors are there. One is of length, other is of area of cross section, and other is the resistivity. Understand? Okay, of the material of the conductor. Now only the thing is that resistivity will not change. Okay, depends on the area of cross section, length, etc. It will be a constant for a particular, but it will change from metal to metal. Okay, substance to substance it will change. That is the resistivity. Understand? So understand here, that is the resistance of a conductor depends on its length, area of cross section, and the nature of its material. Understand? So resistance is directly proportional to the length and inversely proportional to the area of cross section. Understand? So that R is directly proportional to L upon A. So R is equal to rho L upon A. Here the rho is the constant of proportionality and is called the electric. Now this mathematical term is very important. So you have to write it down here. Okay. So it is this mathematical. It is very important. Okay. All of you write down this. Okay, now what is resistivity? Now more about the resistor. So you understand what is resistivity. Okay, so resistivity, what it is? It is a constant. Okay, it depends on the material. Okay, so here the SI unit of resistivity. Now what do we see the resistivity? Okay, resistivity, that is R is equal to rho I upon A. Correct? That is L upon A. Okay, rho L upon A. Now here what is rho then? So rho is equal to, we can say that R into A upon L, we can write like this. Correct? Now what is A? A means area. Area means you know that now when we are converting it into the unit, resistance is of ohm, area is of a meter square, and length is of meter. So 1 meter and 1 meter will cancel, so it become ohm meter. Okay, so the unit of rho is equal to, that is resistivity is ohm meter. Very important. Okay, and the characteristic property of the material and alloy have the very low resistance in range of 10 raised to minus 8 to 10 raised to. Now it is the ohm meter. Now the resistivity of the metal, you know that good conductors. Now the resistivity of the good conductors will be very less. What is the range is 10 raised to minus 8 to 10 raised to Okay, 10 raised to minus 6. Now 10 raised to minus 8 means you know that. Okay, 1 upon 10080 zeros will come. It is so less it is. Okay, 1 upon what it is 1 2 3 4 5 6 7 8. This look 1 upon this much order. It is very less, you know that. Okay, to that is of the metal and some alloys of that much. Now the good conductors, insulators, now it is they are good conductors, but that means now this is very important. It can come for the objective type. Now you know that you will get more objective type this time. So they are the good conductors. Okay, the resistivity of the good conductors is in the range of, okay, there this will be there. So you have to understand it is 10 raised to minus 8 to 10 raised to minus 6. Sure. Now the insulators. Now while telling about the insulators, you know that normally it does not allow the current to pass through it. Okay, that is insulators. Okay, now this insulator's resistivity is 10 raised to 12 to 10 raised to 17. Now again 10 raised to 12, you know that. Okay, it will become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Look, this is a very huge quantity. Understand? So this is of a very huge quantity. That means the resistivity is very high. Understand? So it is the, again, okay, it will come for the exam in objective types or fill-ups like that. That is the resistivity of the resistance. Okay, resistivity of the insulator is in the range of, okay, 10 raised to 12 to 10 raised to 17 ohm meter. Sure that? Okay, both the resistance and resistivity of the material vary with the temperature. Yes, it is sure. Okay, that is resistance as well as the resistivity will change with respect to the temperature. So if the temperature is changed, resistivity will change. No other condition resistivity will change. But the resistance can change by increasing the length and as well as it can decrease by, okay, what? By increasing the area of cross section. But resistivity, if you want to change the resistivity, what you have to do? You have to change the temperature. That is, if the temperature is increased, obviously what will decrease? Okay, resistance will decrease. Okay, so that is the other. So this is also no doubt very important. Okay. Now the other. Now some factors about it is a give reason very important it is of. Now here you can see that, okay, some substance. Okay, that is metals, alloys and insulators, resistivity is given. No need to buy at all these things. Okay, but for your knowledge, okay, you have to keep it in mind. Okay, with the, now in the exam, normally the sums related to this will be there. Okay, then they will provide the resistivity. The resistivity of this is this much, like that it will be provided. So there is no need to, okay, buy it. Okay, so now here you can see, there look, the silver. Okay, the resistivity of the silver is 1.60 into 10 raised to minus 8, correct? The resistivity is copper is, look, 1.62, little we can say more it is. Okay, silver is a very good conductor here, you understand? Okay, copper 1.62, that is better. Okay, now aluminum is 2.63 into 10 raised to 8. Now while seeing it, you can see that mostly, okay, we are using copper in the conducting wires, correct? Why? Because it is having the low resistivity. Okay, but silver also can be used. Yes, but silver cannot be used. Why? Because it is very costly. Okay, that's why copper is normally we are using. Okay, now the aluminum we are telling about. Okay, it is also 2.63 into 10 raised to minus 8. It is less, okay, but more than copper. Again, you know that widely for the, okay, long distance, to carry the current to the long distance, that is high tension wire. Okay, there the aluminum is normally we are using. Okay, now the tungsten, nickel, iron, chromium, etc. is also using, okay, in the different appliances. Now while telling about this, okay, we see that why this alloy is of using, okay, in the especially in the appliances. Okay, the resistivity of alloy is generally higher than that of the constituent elements. Okay, now you know that, okay, if it is of this different alloys are made up of okay, different. For example, constantan. Okay, constantan. Okay, while telling about, okay, it is made up of copper and nickel. Okay, now look, constantan's resistivity is of 49 into 10 raised to 6. Okay, now this 49 into 10 raised to 6 is greater than that of the copper as well as okay, nickel. So the resistivity of the alloy is always generally greater than that of the constituent metal. Okay, take care. Okay, it is a give reason, very important. Okay, now alloy do not oxidize readily at a high temperature. That is the other thing. Okay, alloy do not oxidize, that is burn readily at a high temperature. The temperature is increased, it will not affect the alloy, but the some other metals it will affect. When the temperature is increased, you can say that it will burn, it will start to burn, but alloy will not burn. For this reason, they are commonly used in the electrical heating devices like electric iron, toaster, etc. like that. Give reason, understand what is the give reason here? Give reason it is. Why this? Alloys are using for the electric heating devices. What is the main reason is because they do not oxidize readily at a high temperature. Dusra, the alloy, the resistivity of the alloy is higher than that of the constituent. These are the two reasons for it. Now you know that the tungsten wire. Now tungsten is generally using in the filaments of the electric bulbs. Copper and aluminum are generally used for the electric transmission wires. So it is like this. Sure, all of you? So that is about this. So just now insulators, while telling about, you can see the resistivity of the insulators. Resistivity to insulators is the glass, it is 10 to 10 to 14. Rubber, it is hard rubber, it is 10 to 13, 10 to 16. Paper, dry paper, it is 10 to 12. It is like. Sure, all of you? So this is of the resistivity. Now, so I hope you understand this resistivity very well. It is a very important portion of this chapter. Resistivity. You understand how to derive the resistivity? That is of resistance is directly proportional to resistance is directly proportional to L. Resistance is inversely proportional to area of cross section. So resistance is directly proportional to L upon A. So that resistance R is equal to rho IA. Sure. So rho is the resistivity. Sure. Then unit of resistivity also you may understand, that is ohm meter. Now the next is of the resistivity of the different substances. Sure. Now we will go to the other. Here the resistance of a system. Resistance of a system of resistors. Now this is also very important concern. Now the system of resistors means we know that here when the resistance are connected, now there is some resistance of some quantity, that is we can say resistance of a wire is particular length of wire having 10 ohm, some may have 2 ohm, some may have the 3 ohm, like that it's depends, it will have some resistance value. Now by connecting it together, we can increase the resistance and decrease the resistance. That is very important thing you have to understand about it. Now we can say here it is of now we are having the 3 resistance. We are having 3 resistance, that is of 10 ohm, 5 ohm and 15. Like that we are having, how many resistance are there? 3 resistance are there. Sure. Now while telling about this, now these resistance we have to, by using this resistance, that is now we are provided with 10 ohm, 5 ohm and 15 ohm. It is this much resistance is available. It is represented, resistance is represented by like this. Now there is a combination of resistors. Combination means we can connect it together. Now the resistance can be connected together. Understand? It can be connected mainly in 2 ways. It is of connecting. One is the series. One is the series. What is series means? Resistance are connected one after another. Otherwise end to end we can say. Look. 3 resistors are connected like this. What we done? End to end we connected it. This is of R1, this is of R2, this is of R3. So here the resistors are connected end to end. Understand? Now, when these resistors are connected to end, okay, then the current will pass through it. Sure. So while current is passing through it, the same current will pass through all resistance. Sure. Same current will pass through all resistance. Then, but the potential difference. Now here we are potential, one voltmeter we are putting. So the potential difference, here the other potential difference voltmeter we are putting. Okay, here the other voltmeter we are putting. Understand? Now in this case you can see that here it is of V1 it will be, here it is V2 it will be, here it is V3 it will be. That means okay, potential difference will be different. Okay, at the same time we are going to see here one, okay, like this, okay, at the total end. Okay, here the A, here B. It is the, okay, in this case again B. Now this is also. Now from here we can see that okay, V is equal to V1 plus V2 plus V3. Understand? Getting? Look, here it is. Look, it is X and Y. Okay, in this X and Y, okay, the V is there. Now you know that polarity is very important, plus minus. Okay, now like that. Now so that this is the setup of resistance in series. So how will you say? The resistance are connected one after another in such a way that same current passing through each resistance. Understand? The resistors are connected one after another or end to end in such a way that same current passing through each resistance. Okay, so the potential difference across each resistance will be different. If the R1, R2 and R3 are connected in series, the potential difference across R1 is V1, potential difference across R2 is V2, potential difference across R3 is V3. Okay, so we can say that here, okay, V is the potential difference across the point XY or the, okay, extremes ends of this, okay, resistors. Combination of the resistors. Okay, then V is the, okay, that the total, we can say the resultant potential difference. So here from through the experiment we can see that here V is equal to V1 plus V2 plus V3. Understand? Okay, so from that, okay, we can say that here the when the resistance are connected, in individual detail we will see tomorrow that, okay, in the next class. Okay, so here it is. Okay, when these 5 resistance are connected here in this series, if these 5 resistance are connected in series, okay, now here we can say that here this, if it is connected in series, that is one after another, okay, then the resultant resistance will be, okay, that is resultant with R, it is, we will write is 10 plus 5 plus 15, that is 30 ohm. Okay, now look, the resultant resistance is greater than the individual resistance. Understand? Okay, like that, that is the, okay, what it is? It is the series combination. Okay, now the parallel combination. Now in parallel combination, okay, that is if the resistors are connected between two common points. Understand? Okay, resistors are connected between two common points. That is, many resistors are there. Here the two junctions are there. Okay, we are connected one resistance. Okay, that is the end of all resistance will be at the same point. That is here. There it was end to end. Here it is not like that. End of all resistance will be at the same point. Understand? Then such a combination is called the parallel combination. Understand what it is? It is the parallel combination. So it is very important. Okay, the parallel combination. Okay, so here the parallel combination, okay, there we see that, okay, in series resistance in series, okay, there the current passing through each resistance remains the same. We see that the potential difference is different in different resistance. So the resultant potential difference V is equal to V1 plus V2 plus V3, that we see. But then how it will be there in the parallel combination? Now the parallel combination, the current through the different resistance will be different. That is, it will be I1, I2, I3, okay, I4, it is like this. Okay, the total current passing through will be I. Understand? So here it is like this. But at the same time, okay, you take the potential difference across each resistance and across this common point, it will remain same. That is, the potential difference will remain same. Understand? Okay, in the series combination, current for passing through each resistance remains same. In the parallel combination, the potential difference across each resistance remain the same. Understand the difference? There the, okay, potential in series combination, potential difference is different. Okay, in parallel combination, potential difference across each resistance is same. There the current passing through each resistance is remain same. Here the current passing through each resistor is different. Understand here? Getting? Okay, so now how this current is passing through it will be. So we told that the total current in the conductor is I. Then in parallel combination, it will become I1 plus I2 plus I3. It will come like this. The resultant current passing through the conductor will be equal to the sum of the individual resistance. Individual current. Understand? So as a result of that, we can say that, okay, here it is current while telling about, okay, resistance now while telling about. Okay, now the resistance of this parallel combination will be like this. Okay, that is 1 upon R, that is the resultant resistance will be 1 upon R1 plus 1 upon R2 plus 1 upon R3. It's a derivation, how to derive you will see in the next class. Okay, now here it is 1 upon R. Now we can say in this case, now we are considering it is 1 upon 10, okay, plus 1 upon 5 plus 1 upon 15. Understand? While telling about here, we are taking the common factor. Now common factor, how it will come? It is of 5 is the common, here 2, 3, correct? That is a 2, 3 is 6, 6 30, correct? 30 is there. Now here what will come? 3 will come plus. Here what will come? 6 will come. Okay, here what will come? 2 will come. So which is equal to, what it will become? It is of 12 upon 30, correct? 11 upon 30. Okay, now what is 11 upon 30 is? Now you can say that 11 upon 30 will come 11 upon 30. Now while dividing this 11 upon 30, you can say that it is of point, very small quantity will come. Understand? That is in point will come. Even 1 will not come. Okay, ohm. Okay, that is, now here it is 1 upon R. This is a 1 upon R. Okay, no. Okay, 1 minute. Okay, it is of it is a 1 upon. Now 1 upon R is equal to what it is? 11 upon 30. Okay, so R is equal to, 30 upon 11. Now with 30 upon 11 while dividing, you will get it as 2 point something. Correct? Even 3 will not get that much ohm. Okay, so the resultant resistance is 2 ohm. Now while telling about the 2 ohm or 2.5 ohm, whatever it is, while dividing you are getting. Okay, this 2 ohm is less than 10 ohm, less than 5 ohm, less than 15 ohm. Understand? So if we want to reduce the resistance of a system, we are having 3 resistance, 10, 5 and 15. Okay, when we connected in series, we got 30 ohm. That is, if we want to increase the resistance of the system, okay, we have to connect it in series. But when we connected the same resistance in parallel, the resultant resistance is near about 2.5 ohm. Correct? Okay, so here the resistance is reduced. Then by connecting connecting parallel, we can reduce the resistance of the system. Understand? So that is about the resistance in series and resistance in parallel. Understand? It is very important. It will come even for the distinguish. Sure? Okay, so you must learn this much. Okay, write down this. Okay, and a diagram also. Okay, you have to practice these two diagrams very well. Okay, there the connections will be must be proper, and the polarity is very important. It will come